Question number 19. We have draw the Lewis structure of CF2CL2, and we want to draw all the lone pairs, and we want to use dashes and wedges to indicate the three-dimensionality of the molecule. So there you can kind of see the answer already, but the dashes and wedges would actually be based on what type of molecular geometry we end up having. Okay? So with that being said, CF2CL2, Lewis structure. Okay? So carbon is 14th column, that's 4 electrons. Fluorine and chlorine are both on the 17th column, so that's 7 electrons each. So 7 times 4, that's 28, plus another 4, that's 32 electrons we're working with total. Okay? So now with that being said, alright, we want to make sure that we can actually approach and solve this. We will put carbon in the middle because carbon has the most unpaired electrons. And we're going to draw just a bond for each one. Okay? So fluorine, fluorine, Cl, Cl. And we fill in the octet because each of these was sharing one of its 7. So that's why I'm adding 6 on each side. Okay? And now, with that being said though, let's see what we can do. The carbon is already sharing 4 of its 4 electrons, so that's done. So does this equal 32 electrons? Let's find out. We have 4 bonds, so that's 8 electrons there. And we have plus 6 times 4, so that's 8 plus 24. We do indeed have 32 electrons. So now, for this shape, because we have 4 bonding pairs, it's known as tetrahedral. And the reason why this is important is because of these 4, 2 would be kind of on the same plane and won't be sticking out of the page and won't be going into the page. So we would have something like this. I like to draw it like this personally, where I have these 2 on the same plane, so that would be the 2 fluorines, okay? And then this one right here will be sticking out of the page, and this one, actually, you know what? I like it better like this, where this one's sticking out of the page. I always get confused with this part. This one's sticking out of the page. There we go. And that will be Cl. And this one will be going into the page. That will be the other Cl. So if you kind of rotated it this way to where now the 2 Cls are now the same plane, okay, it'd be now this fluorine is sticking out of the page and this one's sticking, oops, sorry. If we rotated it like that, it would actually, you wouldn't even be able to see this. It would actually kind of look like this, and the fluorine would be behind the carbon. That's what happens when you rotate it this way. That's what we've done. So it's kind of like the fluorine into the page back there. But this is not something that's very easy to draw, which is why we have it like that, where we can show one going out and one into the page. This is the best visual structure we can use to where we can show that with the wedges. Okay? And the last thing I would say is that it's important that when you do draw this, that you have the out and in the page as close together as possible. You typically want it like that. You wouldn't want to draw it any other way. Just how they've drawn it here, they show that the chlorine and the fluorine are both the ones sticking out into the page. Any combination would have sufficed. It's just important that you always keep them near each other. So let's just add now the valence electrons. Okay, so that's 1, 2, 3, 4, 5, 6. And there we go. There it is. And this is correct. And now, let's move on to the last question for today, question number 20. We have